Hello mathematicians, puzzlers, and other curious people. In this video, we are trying to compose two identical triangles into one parallelogram to see if we can find a way to do that. Let's get started. So here we have two identical triangles. This is a GeoGebra build, by the way. And in these two identical triangles, they're both named triangle P, and we have some corresponding points labeled. So here's my idea. I know that a parallelogram has 4 sides. These two triangles collectively have 6 sides. So what I would like to do is kind of mash together 2 of the sides into just part of the inside of the shape. And then at least it'll have the right number of sides. This does not work because it doesn't use up the entire side in one case. So now we have some different kind of shape here, which could be interesting for other things, but doesn't fit with our goal of making parallelograms. So now I've noticed something else. For the 2 sides I mashed together to actually both be eliminated and only be interior parts of the shape now, the sides need to be the same length. So I notice that this side over here looks like it's the same length. Let's see. Okay, so to within the usual level of error of moving things around freehand, I think that's a parallelogram. So triangle P works. Okay, here we have another triangle, triangle Q. So I'm going to try to look for a side that's the same length on both copies. Okay, so I see that that combination doesn't work. And this pair doesn't work. But there's one more thing I can still try. There we go. So it looks like that is the same side, or it's like the corresponding side of the copies. Okay, now I'm having a little trouble getting the pixels to line up just so. That'll happen in a GeoGebra build, but we can use our brains to say, okay, we can see how that's supposed to be. And so, yeah, it looks like triangle Q also can be composed into a parallelogram by using 2 copies. Here's triangle R. So now I'm getting wise to this, and I'm looking for 2 sides that are the same length among the 2 copies, and I see a pair of corresponding points here, the yellow ones that are used for moving the triangles, and the green ones that are used for turning the triangles, and I'm saying, hey, I think that's a corresponding side between them. So let's try this. Okay, that looks like it's working, so triangle R works also. Now I think I'm on a roll and I've got a method worked out. So let's see if it also works for triangle S. Oop, let's line that up better. It works for triangle S. It works for triangle T. It works for triangle U. Let's see if it works for triangle V. Yeah, it looks like it works for triangle V. Here's triangle W. And that brings us back around to triangle P, which now that we know what we're looking for, we see that the thing we found before was also the same as that pattern we found. So there might be other ways for some triangles, but we found at least one way that seems to work for all triangles. Calculator!